Hello, I'm Brian Reid, Professor of Soil Science at the University of East Anglia. We've come out today to have a look at the soils on the East Coast marshes, and then to head inland to have a look at the more conventional arable soils as we head up onto some sands and gravels, and then further inland onto the chalky boulder clay plateau. So we'll start first of all way out of the river, and then we'll make our way back inland to look at the other soils later on.
So the map here shows the flight of the drone. We're going to begin in the north on the marshes. We're going to fly in a generally south direction, stopping to look at soils on the marsh, inland and up on the chalky boulder clay. The second map basically shows where we're going on our field trip. So you can see Norwich is marked in the centre, and the trip itself will take place down around the area of Hales, Norton Subcourse and Raveningham Estate inside the yellow square. Just to recap on the soils of Norfolk, basically there's three major groupings of soils. We've got light sandy soils on chalk drift material in the west. In the centre of Norfolk we've got soils on chalky boulder clay, which can be sandy or clay, and then we've got soils up in the northeast corner of the county which are on outwash sands and gravels and can be sandy or silty. So just to introduce the field trip, we'll now take some short flybys to look at the landscape in the three different regimes that we're going to explore today. So the first short bit of footage is down on the marsh. Second piece of footage, we move inland to soils which are on sands and gravels. Hopefully you can see some changes in vegetation and land use as we move from the marsh to the first of the inland areas. And then finally the last clip, we see soils, or part of the landscape with soils which are on the chalky boulder clay plateau. So we're going to explore these in turn today in a lot more detail.
Alright, so we've got three soil types to have a look at from down on the marsh. This first one I'm going to show you is a peat soil. You might notice from the landscape that it's looking wetter here, there's more weeds than there is further down the marsh. So this material is pure sort of organic matter, more or less. Here. Okay, so we've got basically a topsoil which is organic material, no mineral components really, stone, what have you, but the actual material itself is decomposed plant residues, very organic matter rich. And in this particular location we find this as the floodplain moves up slope onto the regular soils, the arable land, which we'll have a look at a bit later on. Okay, so we've got two other soil types here, also taken from the marsh. We've got soil with the lighter coloured soil, which is a alluvial clay material, and then we have this darker material which is not peat, it's actually a mineral soil, but it's very organic matter rich, which is why it has a darker colour. So here we've got a humus clay surface soil, and here we've got a surface soil which is an alluvial clay. I guess one of the things you might think about in terms of these environments is carbon storage, and the value of these organic matter rich soils like this or the peat soil in terms of their carbon storage potential, in contrast to these alluvial soils which have a much lower carbon content.
So here we can see the general layout of the soils across the marsh area. If we start on the right hand side of the diagram, down nearest the river, we've got soils here which are pretty much sitting on river alluvial. So these are heavier clay soils. As we then make our way back inland, we see soils which have a peat subsurface, but then they return to the alluvium at depth. And then finally, as we come into the edge of the marsh on the inland side, we have soils which are basically peat soils through their entire cross section. So these three soils are the soil series of the Waveney series, the alluvial soils, the Prickwillow series with a peat topsoil and alluvial subsoil, and the Adventurer soil, which is the entirely peat soil in the transect. If we look now at the photographs, we can see these soils look completely different to each other. the alluvial soils down nearest to the river. You can see in the cross section we have a mineral soil, organic matter rich and glayed to the very surface, this AHG horizon. And then below that we've got an E horizon, an elevated horizon, and then below that we have another clay-rich horizon which is enriched in iron, so a strongly glayed horizon in the subsurface. The second soil profile, the Prick Willow series, you can see it's much darker in colour. That's reflecting the peat surface soil, this AOP horizon. And then we have a change in lithology where we have this alluvial section in the soil profile, marked here as a 2BO horizon. And then finally at depth return to the peaty material in the CO horizon. And then lastly we have the adventurous soil, the peat soil. You can see the soil profile is much darker than the other two, which is indicating it's higher organic matter content. And we have very organic matter rich AO horizons, BO horizons and CO horizons, with peat material from surface to subsoil. So we'll now take a fly over the marsh area itself. You'll notice here we're beginning down by the river. Other things that you might notice as we fly across the landscape is that the land surface is flat. There's no real topography as such properly down on the marshes themselves. You'll also notice that as we fly over the landscape that there's evidence of drainage. There's ditches and dikes which have been put in to drain the water from the marshland. You'll see that in terms of land use, we've got some areas around the river itself which are basically just for recreational use. As we come in a little bit from the river, we see a mixture of land which is prepared for arable agriculture and other parcels of land which are pasture based. You might also notice that the landscape is devoid of hedges and trees. It's an open landscape. That's quite a contrast to the soils and the landscape that we'll see further inland. Other things you might be noticing are puddles of surface water, really indicative that the land is not particularly well drained in terms of the soil itself. We've got ponding of water, and clearly the ditches are there to try and remove that water and to pump it out into the river itself and keep the land workable and able to sustain traffic from tractors or grazing from cattle. So we fly in across the landscape. Hopefully you're seeing the three different regimes where we have mainly alluvial soils down on the marsh near the river, and there's transition into peaty alluvial soils, and then finally as we arrive at the edge of the marsh, as we head towards the main road, the vegetation becomes much more green, indicative that something has happened, and here we see the soils which are peat based. So if you move inland now, crossing the main road, we're moving up gradient. You may have noticed the landscape ahead is up a slope from the marsh itself. As we fly inland, you can see that there's a broad plateau where we're going to have a look at the sands and gravels, but then further into the distance you can see the land rise again. This is where we transition and make our way up onto the chalky boulder clay. In terms of land use, we can see that the landscape looks very different to the marsh. We've got soils which are set either to arable, some of those already drilled with their crops, and other areas which are set to pasture. The other thing you'll see which is different is there's now lots of hedgerows, and there's a large proportion of woodland mixed into the farming landscape.
So we've come inland now, and we've headed basically in a southwards direction, and we've come up onto the ridge, and here we have soils which are forming basically on sands and gravels. So very different to the clay, alluvial or the peat soil down on the marsh. Here we've got soils which are very light in texture, very sandy soils. And we'll have a little look across the landscape, and then we'll compare soils which are either in little valley floors where silt material has been eroded and deposited, or back up slope where that material has been eroded, just to leave extremely sandy, very light land up on the plateau tops and on the gentle slopes. Okay, so we're having a look at the soils now up on this area of the estate where basically the soils have developed on outwash sands and gravels. And really here we're looking at soils which have been influenced by the topography a little. So you can see behind me there's a gentle slope which runs down into the foreground. And what's happening in locations like this on the landscape is that silt material within the soil is being eroded and over decades, centuries being removed from the slopes and transported down into the valley floors. So these two soils here, one taken from the slope in my left hand and in my right hand from the valley floor, you can see the slope soil's lighter, it's got a sandier texture, whereas the valley floor soil over here is slightly more loamy. It's not an awful lot more loamy, but it's noticeably more cohesive. It's more sticks together better, as opposed to the slope soil, which is much more sandy, would be much more freely drained, much more prone to drought, whereas the soil over here with the accumulation of silt has got a lot better water storage capacity and probably won't have problems with water shortage in the summer months.
So here in the block diagram we can see basically the relationship between soils which are on a slope where silt material has been eroded and soils which are in the valley floors where the silt material has been accumulated. So this gives rise to two soils, the whole soil which receives the silt and the Raveningham soil where the silt's been removed and you have a much sandier soil. The photograph here shows the sort of erosion of silt that can take place in single dramatic events. You can see here a channel's developed, a rill and gully, and that's washed silt material down the topographic sequence, and then you can see this alluvial fan where the silt material has been deposited across the landscape. In photographs now you can see the Raveningham soil series, which is the sandier of the two, the slope soil, and the Hall series, which in the photographs has got a more cohesive appearance. It's got a darker B horizon. They're the two soils that we've just had a look at with the hand specimens. So we're now going to leave this middle section of the field trip where we looked at soils on sands and gravels. We're currently flying towards the east, but we're going to turn and make our way inland to the south, and to the final destination we will have a look at soils on the chalky boulder clay plateau. As we fly over these parts of the landscape, again just be aware of the land use, very similar land use as we move frame to the chalky boulder clay, a mixture of arable land, some pasture, forest, lots of hedgerow, so in general appearance very similar type of landscape on both the sands and gravels and the boulder clay.
So we've moved now across the estate and we've come further south on our transect, and we've had a complete change in lithology now. The soils here have developed on chalky boulder clay, which is a very different material to sand and gravel. This stuff here is some boulder clay. You can see it's a stiff clay material, and this is what makes up the bottom part of the soil profile here. When we look at the profile that's on the ground, we can see this boulder clay at the bottom. This end. And then as we move further up to the profile, we've got the strong reddy brown mottled horizon, and at the top we have the AP horizon, the ploughed A horizon. So if we have a look at this A horizon, we can see it's actually very different to where we were before. So this is our A horizon now. we've got a material which is dominated by both clay and sand. That's very different to the very sandy material that we had on the sands and gravels. So, very different soil, very different water storage characteristics as well. This A horizon, now we're on the sands and gravels, it's more malleable. You can form it into long threads like this, and you can just about form them round and get them to meet in the middle to form a ring. So we've got a clay-rich material, but it's got quite a high sand content as well, which is why when you do the test it breaks. So we've got a sandy clay loam at the surface of the soil, still relatively freely drained. In terms of waterlogging, not a problem for the surface soil. But as you go further down through the soil profile, we see all this mottling effect on here. This is really indicative of iron oxide and reduced iron. And it tells us that the soil is seasonally waterlogged below the A horizon, and then probably permanently waterlogged down here in this BC horizon, going into the boulder clay properly.
So here in the cross section we have a large soil pit that's been dug, and we're looking at two different soil types here, the Aldby soil series and the Beckles soil series. The soil profile from the auger boring is a good example of a Beckles soil series, and here you can see how the two soils appear side by side across the landscape. In terms of differences, the Aldby series is slightly more sandy in the topsoil, and this allows more oxygen to enter the soil, and it's given rise to this iron oxide rich layer below the AP horizon. You can see that quite clearly in the photograph. In the Beckles soil series, the topsoil is slightly less sandy, it's still a sandy clay loam, and here, because there's less oxygen entering the soil because of the texture, there's less opportunity for that iron oxidation to happen, and because of that the Beckles series doesn't have this iron enriched band in the subsoil. So we're up in the air one final time, and we're just going to move a little further across the chalky boulder clay plateau to our final stop for the day.
This is our final stop on the trip today. We now come to a site which is still on the boulder clay, so similar to the last stop that we made. The difference here is that the sand, which was making the topsoil at the last site still fairly workable, with a relative large amount of free drainage. Now we've got a situation where all that sand has been eroded away, with a soil which is purely based on the chalky boulder clay. So we've got an A horizon now, which is very stiff clay. Compare that to the last site, it's got a much higher sand content. It's much easier to work and to break the soil. Here we've basically got a stiff, almost like a modelling clay. It's a much heavier soil, not free draining, been waterlogged for a lot of the year. Now if we look at the profile itself, we can see evidence of that waterlogging. Down the bottom here, we have these mottled orange and grey areas, which is a feature called glaying, and it's caused by the reduction and the oxidation of iron to give iron oxide patches and grey reduced parts where the iron's been reduced. And we see evidence of this glaying all the way up into the A horizon. So even though the soil is a stronger colour, there's still evidence in here that mottling is taking place, which tells us the waterlogging is present through a lot of the year. Proper boulder clay at the bottom, proper stiff modelling clay material, completely different to the middle location on the field trip. We had soils which were very sandy, loamy sands to sandy loams, on outwash sand and gravel. Now we've got soils which are on clay, which doesn't drain at all well, and the topsoil itself on the soil profile is also very clay rich, almost like a modelling clay as well.
So here in the photograph we can see the hand slope soil series. As already explained, this particular soil series has got a much more clay rich profile, and the very top of the soil is also a stiff clay material. Hopefully you can see in the two images the glaying, which is really evident, and this is being driven by the groundwater fluctuating up and down through the soil profile and driving the oxidation and reduction of iron.
So I hope you enjoyed the field trip today. We've had quite an exploration really, from soils right down on the floodplain and the river valley, onto soils which were on sand and gravel, much more freely drained, and now finally up here on the plateau tops on the chalky boulder clay. We see evidence of how the landscape has been managed, so the original marshland which has been drained, the soil wastage which has gone with that to accelerate the erosion of peat and clay-based materials. And then we see soils in the middle of the transect which are a challenge in dry seasons, very drought prone, very freely draining soils, and sand and gravel themselves very sandy as well. And then finally another challenge in terms of agricultural management. We have soils which are on a fairly impermeable surface, the chalky boulder clay. In some places that clay is all the way up to the surface, which makes working the land very difficult, a challenge in terms of timing. And then soils which, while on the face of it, the surface, are excellent agricultural land in terms of their sand, clay, loamy mix. They also have challenges in the subsurface in terms of water management and the need to be under-drained in order to keep the land surface dry enough, it's trafficable, and the land can be worked, crops can be planted and harvested. So hopefully you've enjoyed that today. The weather's just caught up with us. Thank you very much.